for his family, and hopefully they get through this tough time. Okay. So with that said, we are getting into the last lesson of Unit 2. We're going to be factoring a sum or a difference of cubes. This lesson is going to be a pretty short one, so you guys will probably get to leave before 2 o'clock, hopefully, and maybe not. Just give me 2 seconds. My laptop does not want to charge, and it's going to die soon. Okay, perfect. I got it to work. So like I said, we're going to do a sum or difference of cubes. It's similar to a sum or difference of squares, but just an added exponent. Okay. So hopefully, did you guys find that quiz okay? The practice quiz or whatever, the extra practice? Yes, no, or were some questions hard? All right, perfect. And also for the question, do pineapples belong on pizza? I don't mind a Hawaiian pizza once in a while. I like the taste. I know some people find it weird, but I personally like the taste of Hawaiian pizza. So I'm not opposed to pineapple on pizza, but I know some of you people just dread it. Also, looking at your answers, some of you responded very passionately about the question. Your English teachers would probably be very proud of you guys right now. And yes, I will post the answers to that practice. I just have to print it off the printer and just jot down my solutions, which will probably take me around 10 minutes, and then I'll scan it and post it onto Google Classroom when I get home today. So we're going to start factoring a difference of squares. So that's what we're going to start off with. Remember, when we factor a difference of squares, there always has to be a subtraction between the two terms. And the terms a and b have to have a square root. Okay, so if they don't, a difference of squares cannot be done properly. So with the difference of squares, we have our two brackets. The first one we have x squared minus y squared. So the square root of x squared is just x. And the square root of y squared is just y. So you get x plus y, x minus y as your solution for example A. So the next one we have is 36x squared minus 1. So again, we have our two brackets. We have the square root of 36x squared is just equal to 6x. And the square root of 1 is just equal to 1. Okay? So our difference of squares is just going to be 6x plus 1 and 6x minus 1. The next one is going to be a bit more tricky because we have a expression. So we have 4 times x minus 1 squared minus 6x, 6 to the x times y squared. So we're going to look at both of these individually. So we're going to label 4x minus 1 squared as a and x to the 6 times y squared as b. So we are going to have the square root of 4 is 2. Then we have x minus 1 minus x to the 3 times y. Because when we are square rooting exponents, all we're doing is dividing it by 2. And then on the other side, we get 2 times x minus 1 plus x to the 3 times y. But we are not done yet. What we have to do next is FOIL the 2 into our brackets. After we FOIL the 2, we can expand and simplify the brackets. So what we are going to be left with is 2x minus 2 minus x3 times y multiplied by 2x minus 2 plus x to the 3 times y. Is everybody following so far? Perfect. So again, if you guys have questions, you can just unmute your mic and just speak, and I will answer that question for you. And then the last one, we have 2x to the 5 minus 32x. Does 2 and 32 have a perfect square root? Yes or no? No. So what would we have to factor out first before we can proceed with our difference of squares? So we're going to factor out a 2x. So what we're left with is x to the 4 minus 16. And then it becomes easy. The square root of x to the 4 is just equal to x squared. And the square root of 16 is just equal to 4. So we're left with x squared plus 4 times x squared minus 4. Are we done yet, or is there still one more step that we need to do? Okay, there is one step. Which one of these is a difference of squares again? Okay, so the one with x squared minus negative 4, this is also a difference of squares, okay? So we're going to end up with 2x times x minus 2 times x plus 4. Sorry, not x plus 4, x plus 2. Times x squared plus 4. So remember, with the difference of squares, you are not done until you have no more differences of squares in your factored form. So now we're going to get on to the sum and differences of cubes. So factoring a sum or difference of squares we already did. So we now have two other special polynomial functions, namely a difference of cubes. So we have x cubed minus y cubed, and the sum of cubes is x cubed plus y cubed. So both of those numbers, or if they have a number, they have to have a cubic root, okay? So something that can be expressed to the power of 3. So these could be factored using the factor theorem, but that can become long and tedious. So what we're going to do is ignore this part, okay? Don't even look at this. This just makes it more confusing. So we're just going to focus on this part over here. So when we have a difference of cubes, when it's x cubed minus y cubed, all that simplifies to is to x minus y times x squared plus xy plus y squared. As you can see, with a difference of cubes, the middle term is positive. And with a sum of cubes, you're going to notice the middle term is going to be a negative. So with the sum of cubes, we have x cubed plus y cubed is equal to x plus y times x squared minus xy plus y squared. So we're going to look at some examples, okay? We're going to take a look at the first question, which we have x cubed plus 64. So our a is going to be expressed as x to the 3, and our b is going to be expressed as what? What to the power of 3 gives us 64? 4 to the 3. All right, so we have our x as x and our y as 4. So we come to determine that this is a sum of cubes. So we need to follow the expression x plus y times x squared minus xy plus y squared. So we have our xy, so we have x plus 4 times x squared, and then we multiply x and y together, so we get minus 4x plus 16. So all you're using for a sum and difference of cubes is the formulas that we gave you at the beginning prior to these examples. Okay? So now we're going to move on to B. We have 8m cubed minus 27n cubed. So this is going to be a difference of cubes. Okay? So for our x, what is the cubic root of 8m cubed? How can we express 8m cubed to a power of 3? In terms of 2m? And how about 27n cubed? How can we express 27 to a power of 3? So 3n. So because it's a difference of cubes, we are going to follow the formula of x minus y times x squared plus xy plus y squared. And then all we're doing is subbing in for x and y. So we said our x is 2m, our y is 3n. So we have 2m minus 3n. And then we have x squared. So 2m squared is going to be 4m squared plus x times y. So 2m times 3n, which is 6mn. And then plus 9n squared. So our sums and differences of cubes pretty easy so far. All right, perfect. These won't be included in your, this will not be on your quiz tomorrow. Remember, it's just from 3.1 to 3.4. So our next example we have is 250 x to the 3 times y to the 6 minus 16z cubed. Does 250 have a cubic root? No, it does not. So what number do we need to factor out from 250 and 16 to get us a number that has a cubic root? What do we factor out? Okay, we're going to factor out a 2. So we get 2 times 125, x to the 3, y to the 6, minus 8z cubed. Does 125 and 8 have a cubic root? Yes, they do. So how can we express 125 in terms of a number to the power of 3? So we can get 5 times x y squared to the power of 3. And then we know that 8 in a cubic root is going to be 2. So we get 2z to the power of 3. So now we know what our x and y is, and we know that it is a difference of squares. So we are going to get 5xy squared minus 2z times, now I have to do 5xy squared to the power of 2, which gives us 25x squared y to the 4. I'm running out of room, so I'm going to erase this. Plus 10x y squared z plus 4z squared. Okay. You guys probably think this is not even simplified, but that's the simplest form that this difference of cubes can get into. So we're left with 5x squared minus 2z times 25x squared y to the 4 plus 10xy squared z plus z squared. And yes, there is a 2 at the front. Thank you for that. All right, there's only like 3 more examples after this, and that's pretty much the lesson. So the next one we have 2 minus x minus 1 cubed, or 8 minus x minus 1 cubed. So our x is going to be just 2 to the power of 3. Okay, this is where we can use our let statements, which you guys probably used last year. So instead of working with just x minus 1 to the power of 3, we can just say let a be x minus 1, which means our y is just a to the power of 3. It just makes it easier to work with so that we're not working with a lot of variables all at the same time. So again, this is going to be a difference of cubes. So we're left with 8 minus a to the 3. And we know our x is 2 and our y is a. And then we just follow the formula. So we get 2 squared, or 4, plus 2a plus a squared. So what is left for us to do in this question? Do we just leave the a's there, or do we have to do something with them? So we're going to sub x minus 1 back into a. So we're going to get 2 minus x minus 1 times 4 plus 2 times x minus 1 plus x minus 1 squared. And then we just have to expand and simplify. And we get 2 minus x minus plus 1 times 4 plus 2x minus 2 plus x squared minus 2x plus 1. The two x's cancel each other out. So all we're left with is 3 minus x times x squared plus 3. So like I said, with a difference or sum of cubes, all you're using is the formulas we gave you for them. Remember, the middle sign is always opposite. So if it's a difference of cubes, your middle term when you expand is going to be positive. And if you have a sum of cubes, the middle term when you expand is going to be a negative. And last but not least, we are going to move on to the last example. So we have x to the 9 minus 512. So both of these have a cubic root. So the cubic roots are x to the 3 to the power of 3 minus 8 to the power of 3. So our x cubed is going to represent our x. So this represents x, and our 8 is going to represent our y. So we're going to be left with x cubed minus 8 times x to the 6 plus 8x cubed plus 64. Are we done yet, or do we have another difference of cubes here? Okay, there is another difference of cubes here, and that's x to the 3 minus 8. Okay, so this is another difference of cubes. So we know the cubic root of x to the 3 is just x, and the cubic root of 8 is going to be 2. Okay, so again, this represents our x, this represents our y. So what we're left with is x minus 2 times x squared plus 2x plus 4 times x to the 6 plus 8x3 plus 64. The trinomial, we leave it because it's neither a difference or sum of cubes. And you can't factor it because you can factor it using the factor theorem. But from when I tried it, it's not factorable, so it wouldn't give you whole numbers. So you would just leave it as is. But if you can simplify that trinomial, then you can simplify it. Then I would suggest you do that. But if you can't, then just leave it as is. And then we have the last two examples. So for this time, with the difference in sum of cubes, we are going to use our factor theorem. So what we did yesterday to try to factor the sum and difference of cubes. So again, we've done so many factors of 8, so I'm pretty sure you guys know the factors of 8. So the factors of 8, we have our plus and minus 1, plus and minus 2, plus and minus 4, and plus and minus 8. And P of Q just gives us back the set of P. So remember with factor theorem, the factor we choose has to make that function give us an output of 0. So what factor of 8, when we plug it in to the f of x, is going to give us 0? Positive or negative 2? So we're going to get f at negative 2 is equal to negative 2 to the power of 3 plus 8, which gives us negative 8 plus 8, which gives us 0. So x plus 2 is a factor. Okay? So now we're going to use synthetic division. And you're going to be like, and once we do this, you're going to figure out that it's actually pretty easy using synthetic division and factors theorem. But sometimes it can take forever, so don't try using it all the time. So we have 1, because x to the 3 is our highest degree. We don't have any x squareds, so we have to put the placeholder of 0. We don't have an x to the 1, so we put another placeholder of 0. And our constant is 8. So like we've done so many times already in this unit, you drop the first number, you get a 1, and then you multiply. So you get negative 2, 0 plus negative 2 is negative 2. You get 4, and then these cross out, which gives us 0. So what you're going to see here is this sum of cubes already factored for you using synthetic division. So our f of x is equal to, because x is equal to negative 2 is a factor. When you bring it back into the bracket, it gives us x plus 2. And then we get x squared minus 2x plus 4. Does this simplified expression over here correspond to the formula I gave you in the beginning for the sum of cubes? Yes. So as you can see, you can actually do a sum or difference of cubes by using the factor theorem. And we are going to try the last one out. So we have 8x cubed minus 1. So the factors of p we have are just 1. And the factors of q we have are plus and minus 1, plus and minus 2, plus and minus 3, plus and minus, not plus and minus 3, sorry. Plus and minus 4 and plus and minus 8. And here we actually have to do p over q because it just doesn't give us back the set of p. So we got plus minus 1, plus and minus 1 over 2. We got plus and minus 1 over 4, and plus and minus 1 over 8. So which one of those factors of p over q, if we plug in for x, gives us an output of 0 for the function? I'll give you guys a couple seconds or minutes to figure that one out. And whoever has the answer, just let me know on the chat. Okay. So does everyone agree with 1 over 2? So let's plug in f at 1 over 2. So that gives us 8 times 1 over 2 to the power of 3 minus 1, which gives us 8 times 1 over 8 minus 1, which just gives us 1 minus 1, which equals to 0. So f of 1 over 2 gives us 0, which is good, because that means 1/2 is a factor. So now all we have to do is use synthetic division again. So we have 8, 0, and 0 because we don't have an x squared or an x. And our final one is just minus 1. So we're going to drop the 8. 8 times 1/2 is just going to be 4. And it's going to be 2. And then it's just going to be 1. So when we factor this difference of cubes, it is going to give us back f of x is equal to 2x minus 1 times 8x squared plus 4x plus 2. What can we factor out from the second trinomial? So we're going to factor out a 2. And that would be your final answer. So is everyone okay with the sum and a difference of cubes? Remember, you can do it 2 ways. You can do it using the formula and just finding the cubic roots of the first and last term, or you can use the factor theorem and then use synthetic division to factor it out. Whatever way is more comfortable for you. I don't mind which one you pick, but if I ask use this specific way to do it, then I want you to do it that specific way. All right. So other than that, that's pretty much the lesson today. It is a short one. So you guys have time to study for your quiz tomorrow, and you have time to work on the homework for 2.6, sorry. And then tomorrow you will have your quiz, and we'll probably give you class time tomorrow to work on the chapter review. And remember, your thinking and application part of this unit is going to be on Tuesday. Tomorrow's class is in the afternoon. I don't have any of you guys tomorrow. So we're back online at 1:05. And on Friday, I will see cohort B. So you guys can feel free to log off and go do your work.